MATLAB online lecture series by Professor K.V. Narasimham. Today's topic is MATLAB as a calculator. Now, this is the continuation of the previous class. So, in this class, we will discuss about how to use our MATLAB as a calculator, how to compute the simple computation using MATLAB. Already we discussed a few computational procedures. So, arithmetical operators are already discussed: addition, subtraction, multiplication, division. So, we have two types of division, left division, right division already discussed, and also assignment operator and power operator is also discussed. Now, coming to basic functions. So, exponential function is denoted by exp and logarithmic natural logarithm is denoted by log. And base 2 is denoted by log 2, base 10 is denoted by log 10, already we discussed, and also square root sqrt square root function, and also we discussed about the trigonometric function. Again we will discuss about trigonometric functions. Here sine, sin d, sin pi, default functions, commands, a sin d, sin h, a sin h. Okay, we will discuss one by one in the software. Sine function. Suppose, okay, I will change the font size. Wait, very simple method. A sine function, okay, sin of 10. So, here 10 is in radians, okay, sin 10 equals to minus, okay, I will remove this one, okay, for more visibility. Sin 10 equals to this one. Here 10 is in radians, 10 in radians. Suppose if you want to find the sine value in degrees, now use sin d function, 30 degrees, that value is 0.5. Suppose if you write sine of 30 in radians, you will get another value. CLC, clear the screen. In the similar way, sin pi function. What is the meaning of sin pi function? I will explain. So, first one is sine of some function, here x in radians, already we discussed. If it is in degrees, x in degrees, use sin d of x function. Now, coming to sin pi of x, what is the meaning? This is nothing but sin pi x. In mathematics, sin pi x is denoted by sin pi of x. So, simply suppose if you want to know the value, example sin 7 pi by 5, 3 pi by 5 of x, if you want to find the value, simply use sin pi of 3 by 5. No need to write pi here, no need to write pi here. So, simply write pi. Another example, suppose if you want to find sin 3 pi value, simply use sin pi of 3. So, very simple procedure. Sin pi of 3 by 2, this value is minus 1. Sin pi of 1 or 3 is 3 pi, this is nothing but 3 pi value. So, in the similar way, this is a sin pi function. In the similar way, suppose if you want to find sin inverse x, sine inverse x, use the command a sine of x. Suppose if you want to find the value of sine hyperbolic of x, use sine h. Suppose if you want to find sine h inverse of x, use a sine hx. Okay, very simple. So we will verify all these conditions. CLC sine a sine of 3, then what happen? You will get a complex number. So because sine range is -1 to 1, give the values from -1 to 1 only. So I will give 0.8, sorry, 0.8. You will get the corresponding value in radians. Okay, then no problem. In the similar way, now check it. If degrees in radians, use a sine d of 0.8. Now you will get the value in degrees, 53 degrees. In the similar way, hyperbolic function sine h of 2. This value is same as, what is the sine hx? What is the sine hx procedure? Sine hx is known mathematical expression or equation, e power minus equivalent to e power minus, sorry, this is minus e power x minus e power minus x by 2. So you will use, we will verify just for understanding. Okay, exp of, so 2 minus exp of minus 2, okay, divided by 2. So you will get the same value, 3.6269. So this is nothing but sine hyperbolic function. Suppose if you want to find the inverse hyperbolic function, again use a sine h, inverse hyperbolic function. So use a sine h of 2 or 3, okay, 23, then no problem. So this is nothing but sine h inverse of 23 value is 3.8291. In the similar way, for cos functions, now observe cos functions, very simple. Cos for radians, cos d for in degrees, cos pi, a cos d, cos h, a cos h. In the similar way, next one is the tan. So use the tan d, a tan d, a tan d, so etc., etc., etc. Okay. In the similar way, use all these commands for tan function. Now cosine, CSC, cosine function. CSC, CSCD, and remaining all scalar same. Okay. So last one and first one are same, don't worry. Now secant SEC, secant, cot, square root of sum of the squares is hypertune. Okay, we will use all these functions for trigonometric purpose. Okay, we will discuss one by one just for understanding. CLC, cos of 2, cos d of 2, 23 degrees. Okay. Next, cos pi of 3, cos 3 pi, value is -1. In the similar way, a cos of 0.99, value is this one. In the similar way, hyperbolic cos cos h of 2.3, you will get the corresponding value. So in the similar way, we can find all the values of cos. In the similar way, tan of 23, tan d of 60 degrees, tan 60 is 1.7321 root 3 SQ RT of 3 with just verification. So you will get 1.7321. In the similar way, cosecant of 2, so 1 point some value. Now secant of some 2, you will get the value, corresponding value. Cot of some 23, you will get the value. So what is the conclusion here? For any trigonometric function? So if you observe direct sine or cos or any one, directly x in radians, d means x in degrees, pi means pi function. Okay. So any trigonometric function, now try to understand sine of x. If x is in radians, cos x, tan x, cosecant x, secant x, next cot x. If x in radians. Now if x in degrees, use sine d of x, cos d of x, tan d of x, the cosine d of x, and etc. So in the similar way, sine pi x, nothing but sine pi x, cos pi of x, tan pi of x, etc. In the similar way, arc sine of x, a sin x, a cos x, a tan x, etc. for inverse trigonometric functions. Next one is hyperbolic. So sin hx, cos hx, etc. If it is in degrees, use d here. Okay, sin d of x, cos d of x, and etc. Hyperbolic inverse hyperbolic function, a sin hx, a cos hx, etc. So very simple trigonometric functions we can use easily. We can use trigonometric functions for calculation of trigonometric function. It is very easy. Suppose if you want to find we will use the hypot for square root of the sum of the squares. Okay, we will discuss later in corresponding subject. Now coming to mod function, very important one, important function. Okay, we will discuss one by one. Another function, mod function, modulus function. Now try to understand. Very easy. Mod of 2.5, 2.4. Wait. Remainder after division. Okay, wait. Mod of mod of mod of 23 comma 5. Okay. What is the value? So modulus of 23 comma x. Now what is the syntax here? Mod x comma divisor. So what is the example here? Mod of 23 comma 5. So divide 23 with 5 4 times. So what is the remainder? This is the called the remainder. So remainder is 3. So this is our methodology. In the similar way, check another one, mod of 35 comma 3. Then what happens? You will get 2. 11 3s are 33, so remainder is 2. So what is the mod function? Remainder after division, modulo operator. Okay. Remainder after division, modulo operation. So now coming to remainder function. Remainder function, CLC. Suppose if you want to know the details of remainder function, simply type help rim remainder function. So remainder x of, now observe, remainder after division. Now observe. Now this is the concept remainder. Carefully compute to avoid rounding errors. If y is not an integer, then quotient is then round of error of an integer. Now listen carefully, I will explain. Before going to the mod function and remainder function, we will discuss about 3 more functions, then we will discuss the mod and remainder function. Usually mod and remainder functions are look like similar if both are positive sign. If one of the integer is or one of the number is negative, then you will get different form. Okay, we will discuss. So before that, first we will discuss about the function fix. What is fix? Fix function. So fix of x. So for example, fix of 12.2. Now what is the fix? Fix of 12.2. So what is the nearest value towards 12 is, towards 0 is 12. Okay, this is 0, here 12.2. So nearest integer towards 0, what is the nearest integer? 12. Suppose if you take minus 12.2, here minus 12. Okay. So nearest value we will discuss one by one. So 12 fix 12.2 is 2, fix minus 12.2 equals to, so nearest value is, now this is minus 12 minus 13. Okay, here minus 13, so minus 12. Okay, we will discuss one by one. Okay, so I will explain again. First we will discuss about the fix function. Okay, I will erase again, I will explain clearly. Fix function. Fix function. Suppose this is x, this is 0, some x is there, whether it is fractional or integer or rational number. Now find out the nearest integer towards 0, some n, you will get, this is x, this is n. So then nearest integer is n. Suppose if it is negative value, suppose for example minus x, now find out the nearest value. For example, fix 12.2. So nearest to 12 integer is towards 12 is 12.2 is 12. Fix minus 12.2 is nearest one is minus 12. Okay, we will discuss, I will show you in the software. Fix 12.2 is 12. In the similar way, fix minus 12.2 is nearest integer towards 0 is minus 12. That is fixed function round towards 0, rounding towards 0, rounding towards 0. This is very simple function. So, rounding the number near to 0, towards 0, not near, towards 0. Suppose for example, fix 7.8, rounding to nearest to 0 is 7. Fix minus 7.8 is minus 7. So, this is about fixed function. In the similar way, ceiling function. Now observe, ceiling function. Ceil, S-E-I-L, ceiling, round towards positive infinity. Now listen carefully. Ceiling function. Round towards positive infinity. Suppose if it is our number, some x. Now find out the nearest integer towards positive integer. For example, ceil of 12.2. Now now this is 0, 12.2. So towards positive infinity, next integer is 13. Suppose if you take ceil of minus 12.2, so this is also same, minus 12.2 towards positive value. So rounding to nearest integer, that one is minus 12. So little bit different from fixed function and this one. So this is about ceiling function. I will show you in the software. CLC, ceil of 12.2, you should know the differences. 12.2 is 13, ceil minus 12.2 is minus 12. Okay, already we discussed it, CLC. Next, flooring, floor function. Fourth one is floor function. So rounding towards negative infinity, okay. Right, okay. So fix 12.2, okay, I will fix the same value. So here 0, 12.2. So towards negative infinity is 12. Sorry, this is not floor. Floor of minus 12.2, here minus 12.2, towards value is minus 13. So minus 13. So first we will discuss all these things, 1, 2, 3. Three functions. You should know the difference between these three, then only you can find the value. Okay, this is origin, this is plus infinity, this is minus infinity. Now this is 1, 2, 3, 4 integers, minus 1, minus 2, minus 3, minus 4, conclusion. Suppose if you take any number, okay, if you take any number, rational number or fractional number, then no problem. Then what about fix? What about ceil? What about floor? Floor of x. So this is rounding towards 0, towards 0. This is rounding towards positive infinity, positive infinity. Now this is rounding towards negative infinity. Suppose if you take any number here, okay, I will take any number. So rounding towards 0 is nothing but 2, nothing but fix. Suppose rounding towards negative infinity is also 2, nothing but floor. Okay. Now coming to rounding towards positive infinity is 3, nothing but ceiling function. Okay, very simple logic. So you should know the difference between fix 12.8, fix minus 12.8, seal 12.8. So this is fix, seal minus 12.8, floor 12.2. What is floor? Minus 12.8. So what about the values? Very easy. Okay, I will write 0 here, 12, 12.8. Okay, I will write minus 12, minus 12.8, then minus 13. This is towards positive infinity, this is towards negative infinity, this is origin. Fix means towards origin. So 12 towards origin is 12. Now minus 12.8 towards origin is minus 12. Okay. Ceiling of this number towards positive infinity, that value is 13. Ceiling of minus 12.8 towards positive infinity, that value is also minus 12. Floor of 12.8, floor of 12.8 towards negative infinity, is 12. Floor of minus 12.8 towards negative infinity is minus 13. You should know the difference between these three functions: fix, seal and floor functions. Okay, now coming to after that mod function, modulus of a comma b. So modulus of a comma b is nothing but a minus b into floor of a by b. Remainder function is a by b, a minus b into fix of a by b. So you should know the difference between these two. If both are same sign, you will get the same values. Okay. If both are same positive sign, you will get same values. Both are positive, you will get the same sign. Okay. Okay, I will show you one example. Mod 23 comma 5. So okay, I will take 23 comma 5, then no problem. So what is the procedure? 23 minus 5 into mod function, floor of 23 by 5. So this value is 23 minus 5 into 23 by 5. 23 by 5 is 4 point something. Floor is nothing but towards infinity. 4 point something is nothing but 4. Nothing but 25 minus 20. This value is 4 point some value. So towards negative infinity, the value is 4. So 20 the value is 3. Okay. Remainder function of 23 comma 5. Okay, 23 minus 5 into fix 23 by 5. Then what is the value? 23 minus 5, fix of 4 point some value. So towards 0 is again 4. If both are positive, you will get the same value. There is no significant difference between mod function and remainder function. Mod function and remainder function. Okay, I will show you in the software. Mod of 23 comma 5 equals to 3. Remainder RAM, remainder of RAM of 23 comma 5. Okay, you will get the same value. But very, very important, if one of the term is, second example, if one of the term is negative, then how to find the value? I will take 10. Okay, simply I will take bigger one. Then what is the meaning? Minus 4 minus 10 into floor of minus 4 by 10. Minus 4 minus 10 into floor of minus 4, that value is minus 0.4 something inside value. So floor value towards infinity, this is 0, this is minus 1, so middle minus 0.4. So towards infinity, that value is minus 1. So that value is minus 4 plus 10 equals to 6. Now suppose if you want to find the remainder function of minus 4 comma 10, minus 4 minus 10 into fix of minus 4 by 10. Minus 4 minus 10 into fix of minus 0.4. So fix is nothing but towards 0. So this is minus 0.4. Towards 0 is next rounding to the towards 0 is 0. So minus 4 minus 10 into 0 equals to minus 4. Okay, I will give you CLC mod of minus 4 comma 10. So value is 6. Remainder function of minus 4 comma 10, you will get minus 4. So you should know the difference between these two. So in the similar way, try for another. This is just for interest purpose. Modulus of minus 8 comma 10. What is the value? What is the remainder of minus 8 comma? Okay, I will take 38. I will take 38. Minus 38, 10. What is the procedure? Minus 38 minus 10 into floor of minus 38 by 10. Minus 38 minus 10 into floor of minus 3.8. So minus 38 minus 10, floor is nothing but towards infinity, infinity is minus 4. So minus 38 plus 4, 40. Minus 38 plus 40 is nothing but 22. In the similar way, remainder function minus 38 minus 10 fix of minus 38 by 10. Minus 38 minus 10 into fix of minus 3.8. Towards 0, here towards 0 minus 3.8. Now this is next rounding to next towards 0 is minus 3. Minus 38 minus 10 into minus 3. That is minus 38 plus 3, 30. So value is minus 8. Okay, I will check the value. Mod of minus 38 comma 10. Value is 2. This value 2. In the similar way, REM of minus 38 comma 10 is minus 8. So you should know the difference between remainder function and mod function. So very simple. Okay, what is the definition? Mod of a comma b equals to a minus b into floor of a by b. So remainder function a minus b into fix of a by b. If both are scalar quantities, if a and b are both are scalar quantities, then only this formula is valid. If it is vector quantity, we will discuss later. Okay, then how to find the mod and remainder functions. Okay, very simple. So here we discussed about total 5 different functions: fix, floor, seal. Okay, then mod function, remainder function. So this one is totally different, round to nearest decimal point. Okay, okay, I will show you. CLC help, just for understanding I will write round, help, take the so syntax is round x comma n. N is the positive integer. For n is the positive integer, rounding to n digits. How many digits? Very simple. Okay, CLC round, ROUND, round of 3.1 2 3 4 5 6 7 8. Okay. Okay. So I will rounding to 6 decimal places. Because our format is short format, then only you will get format long. Okay. Then you will get 6 decimal places, rounding to 6 decimal places. 6 decimal places. 3, 6, 7 is rounding to this one. Okay. So we will discuss later in detail how to manipulate all these things. Okay, we will discuss later in detail. Format short is the default 4 digits. Suppose if you want to 3 decimal places, what happen? Okay, rounding to 3 decimal places. 4 is less than 5, so decimal places is 3. Okay, we will discuss later. So here we will discuss total very important functions: ceiling function, fixed function, floor function, mod function, remainder. All these things are very important for programming purpose. Okay, this is totally different, we will discuss later. Now coming to next topic is variables. What is variable and what about the variables, we will discuss later. Okay, now some practice questions. Complex variables. Suppose now coming to another one is complex numbers. Okay, I will explain. Suppose if you want to, already we discussed in our earlier class how to write a complex number. Very simple, 1 plus 2i or 2j, both are same. Y equals to 3 plus 2 plus 3i. Okay, then no problem. So you will get 2 complex numbers x and y. Suppose if you want to find ABS of x, absolute value of x, then what is the meaning? A equals to 1 plus 2i. ABS function. ABS function. ABS, absolute function. This is nothing but ABS of 1 plus 2y. Okay, am I correct? ABS. Example, Okay, 1 plus 2y. ABS of 1 plus 2y. Absolute value is square root of 1 plus 2 square. 1 plus 4 is nothing but root 5. SQRT of 5. SQRT of 5 is same as ABS of the complex number 1 plus 2y. This is first one. Okay, wait. Now angle, phase angle. So theta equals to tan inverse A by B using the formula. So angle ANGLE, angle of x, complex number. Okay, tan inverse tan inverse B by A, B by A. So tan inverse B by A. So angle is nothing but another function in complex variables. Angle equals to angle of x is nothing but angle of 1 plus 2y is nothing but tan inverse 2 by 1. So angle of A plus bi is nothing but tan inverse of b by a. So tan inverse of b by a is nothing but our code is a tan 2. Our command is a tan 2 equals to, you will get the required value. Now coming to next one is complex. So create, suppose if you want to create a complex, you will use conjugate complex. Okay, I will conjugate complex CONJ of x, nothing but 1 minus 2i. Okay, I already we discussed imaginary part, real part. Okay, IMAG of x, imaginary part of x is 2, real of REAL, real of x is 1, 1 plus 2i 1. So these are all complex variables. So now coming to some practice questions. Okay, I will explain one by one. Now what is the value? Now calculate all these values using our software. Now coming to our question, just for understanding, I will copy this one. First time I will copy this one, then later stage we are not required. So then how to write this value? Okay, how to write our MATLAB code? Now total whole square. Okay, so this is 5 minus 19 by 7 plus 2.5, power is nothing but caret symbol, now bracket caret 2. Now simply type this one, you will get the required value. Bracket 5 minus 19 by 7, okay, plus 2.3, what is the value? 2.5 whole cube, 2.5 power 3 power 2. So you will get the value. So this value is 320 value. In the similar way, now calculate 7, this is not x, 7 into 3.1 plus square root of this value. Okay, Now second one, and then how to write the code. First 7 asterisk 3.1 plus first one is SQRT of 120 divided by 5. You may write in bracket, then no problem. 15 power 5 by 3. Use bracket, proper brackets, then you will get the solution. In the similar way, find out this value and this value. Just all these things, just take the screenshot. Take the screenshot of this one, then solve all these problems. So this is trigonometry. Okay, I will calculate this value. Calculate this value. Very simple. So first value in pi. So sine pi of 0.2 divided by cos pi. So if it is pi, then no need to write again. 1 by 6, okay, plus tan in degrees, so write d 72, okay. In the similar way, find out the remaining. Now evaluate this value. Okay, we will discuss later this one. Okay, after completion of variables, we will discuss this question, okay, this question, and remaining. Okay, don't worry. Okay, we will discuss later remaining questions. Just up to third question. Up to third question, just solve it. We will discuss the remaining questions in the next class. Okay, if you have any doubts, now mail to me or WhatsApp to me. So my WhatsApp number is 98662 78504. My email ID NARASIMHAM_KV@yahoo.com. So if you have any doubts, then ask me. Okay, meet again. We will discuss another topic, variable concept, in next class. Variables, then vectors, matrices, and everything we will discuss in next class. Okay, thank you very much. Meet again.